Number 4, we need to solve the differential equation, use a graphing utility to graph 3 solutions, one of which passes through the given point. So here's our differential equation, dr dt. Now, dr dt means that the function is called r and the variable is t, because that's the derivative of r with respect to t, equals secant squared t divided by the tangent of t plus 1. All right, and then once we've done this, the point that it needs to go through is pi 4. All right, so we multiply both sides bt by dt, and then we take the integral of both sides. The integral of dr is r, so r equals the integral of secant squared t divided by the tangent of t plus 1 dt. I think we probably need a u for this one. What do you think u might equal? Now we got battling guidelines. We got a quantity secant of t with an exponent on it, but we've got a quantity in the denominator. Let's try letting u equal tangent of t, oops, and I forgot to write, plus 1. All right, here's why this works. You got to know your trig derivatives and integrals well enough to see what's the tangent of t, or what's the derivative of the tangent of t. It's secant squared of t, okay? So by choosing u that way, the secant squared of t gets tied up in the du, okay? Oh, no one won't follow that, will it? So du equals, well, the derivative of the tangent of t is secant squared t. Derivative of 1 is 0. Don't forget your dt. Well, I think I can make a substitution now, can't I? I've got that integral. The tangent of t plus 1, I can replace with u. And then secant squared t dt, I can replace with du. What's over my u then? A 1, because multiplying by 1 never changes it, so don't leave it blank. It's a 1. So that's what r equals. R equals the integral of 1 over u du. All right, well, that's a lucky break. I know what the integral of 1 over u du is. It's the natural log of the absolute value of u plus c. And I even know what u equals. It equals the tangent of t plus 1. So replace u with the tangent of t plus 1. So that's our general solution. Now we get our particular solution by using the point pi 4. So I said at the point pi 4, what happens? Now, normally that's xy, right? Which one's the x and which one's the y? The r is which one? The t is which one? T is x, r is y. R is the name of our function, so it's the y. T is our variable, so it's the x. So replace, in your general solution here, replace r with 4 and replace t with pi to give us 4 equals the natural log of the absolute value of the tangent of pi plus 1 plus c. All right, work inside your absolute value signs there. What is the tangent of pi? Zero. So 4 equals the natural log of the absolute value of 0 plus 1 plus c. Well, 0 plus 1 is 1. The absolute value of 1 is 1. Absolute value of 1 is 0. No, you're a step ahead of me. Okay, I got you. And what does the natural log of 1 equal? 0. See, you kids these days just move faster than us old people. All right, now that we know what C equals, there's our particular solution. So R equals the natural log of the absolute value of the tangent of t plus 1 plus 4. All right, then we were supposed to use our calculator to graph this. So I did. All right, so I typed in for y1 the natural log of the absolute value of the tangent of x plus 1. And I had to close the parentheses after the x so that it's just the tangent of x, and then plus 1. Then I had to put the parentheses around that for the absolute value, and then the parentheses around that for the natural log plus 4. And that gave me this one here in the middle. Is that what you get? Yeah, because it said it wants 3 graphs or 3 solutions. That's the one we found. That's the plus 4. But then it wants 2 other general solutions, or actually 2 other particular solutions that we get from the general solution. So all I did was take what I'd already typed in, y1, added 1 to it for the second function, and subtracted 1 to it from it for the third one. Y'all don't know how to do that?
Oh.
Okay, so we put in y1. Natural log of, let's see, where do I find absolute value? Right there, absolute value of tangent of x, close the parentheses on the x, plus 1, close the parentheses on the absolute value, close the parentheses on the natural log, plus 4. So I get that. While I'm thinking about it, I'd better change to radians here. All right. Then to do that, I go to, see where it says VARS, right there where the cursor is, variables. Then move over to Y variables. And our Y variable is going to be a function. And we want Y1. That's how I get Y1 plus 1. Then I do the same thing. Variables, Y variables, function. This time I want Y1 plus, nope, I did minus 1. And then I graph these things. Why not? You got some little cheap graphing calculator? It will use somewhere on there. You've told it not to graph more than one thing at a time. All the little equal signs have the, yeah.
And when I hit the graph button, then I go back, the second 2 are off.
Yeah, somewhere on there. I don't even know really where to look. Man, you've got a setting there somewhere. My calculator came with a manual. That's true. I'm sure somebody showed me how to do that. All right. We okay with 40? You're supposed to do what I did. You're supposed to do it with your TI-83 emulator on your computer and then print out the screen. Duh. Ooh, maybe it does. All right, number 44. Let's see, what are we doing on 44? Looks like we have a slope field. So a differential equation, a point, and a slope field are given. Our differential equation is dy dx equals the natural log of x over x. Our point is 1, negative 2, and you can see the slope field. Sketch two approximate solutions of the differential equation on the slope field, one of which passes through the given point. All right, so I did that. Okay? You just got to try. You don't know how good it's going to look, but you do that. Then you have slopes like so. Then you have really steep slopes like so. Then you just choose another one. All right, so we can get a graph, a sketch of a graph, even if we're never able to solve the differential equation. But I think we can. So part B, use integration to find the particular solution of the differential equation and use a graphing utility to graph the solution. All right, so let's solve this thing. So we've got dy dx equals the natural log of x over x, and the point that we'll get our particular solution to go through is 1, negative 2. So you multiply both sides by dx, and then you take the integral of both sides. The integral of dy is y, so y equals the integral of the natural log of x over x dx. And here we break our guidelines. In the last one, it worked out pretty well to use the denominator as our u. The reason it worked out, though, was because the numerator was the derivative of the denominator. So that's why that worked out. Don't let u equal x. That doesn't get you anywhere. So the only thing left to try is to let u equal the natural log of x, which works out great. Because once I let u equal the natural log of x, what's du equal? Well, it equals the derivative of the natural log of x dx. The derivative of the natural log of x is 1 over x. So du equals 1 over x dx, which is exactly what we have. Now, you don't have to rewrite this, but couldn't I rewrite that integral to be the natural log of x times 1 over x dx? Isn't that the same thing? So I've got exactly what I want. Okay? So do the substitution. Replace the natural log of x with u. Replace 1 over x dx with du. So y equals the integral of u du. You follow me on all that? All right, well, it's a piece of cake from here, isn't it? So just power rule it, add 1 to the exponent, get a u squared, divide your coefficient by the new exponent, so your coefficient's a 1/2 plus c. Then replace u with what it equals, which is the natural log of x. So y equals 1/2 times the natural log of x, quantity squared, plus c. That's our general solution. Use our point, 1, negative 2, to get our particular solution. So replace x with 1, replace y with negative 2. The negative 2 equals 1/2 times the natural log of 1 squared plus c. What is the natural log of 1? 0 squared is 0. 1/2 times 0 is 0. So all you have on the right side is c. So negative 2 equals c. Now you can replace c with negative 2 to get the particular solution. All right. And let's see how close we come here. So let's see, what's our particular solution? 1/2 times natural log of x squared minus 2. Yeah, not bad. We okay with 44? Any questions on 44? All right. Which one do you think is next? Close, 52. That was close. Evaluate the definite integral. Use a graphing utility to verify your result. Yeah, some of you tried to bluff me on the test, didn't you? Didn't have a clue how to work number 19. Just wrote some stuff down that had nothing to do with the problem, then punched it in the calculator. Nice try. All right, so what do you think y'all let u equal? Yeah, you know, we don't really have a good thing. No, neither one of them have an exponent. Guess the one in the denominator. That's the place to start. So let u equal x plus 1. So what's du equal? Yeah, it just equals dx. Okay, now, in anticipation, I know I'm going to have to change the limits of integration, all right? What I've got so far is I've got a u right there. I can replace dx with du, but then I'd still have an x. So I'm going to need to replace that x as well, aren't I? So that u equals x plus 1, subtract 1 from both sides, and let's get u minus 1 equals x. So I'll be able to take care of that x now, won't I? So the substitution is going to work now, but I have to change my limits of integration. So if x equals 1, I need to figure out what it would be for y, or for u. So if x equals 1, then u equals, well, u is x plus 1, so 1 plus 1, so it's 2. And if x equals 0, then u equals 0 plus 1, so it's 1. So our limits of integration change. And now we're ready to make our substitution. So the integral is now going to be from 1 to 2. The x plus 1 in the denominator is replaced with u. The dx is replaced with du. So I've replaced all of that so far. The negative 1 in the numerator stays negative 1. What does the x become? So u minus 1. And now, because now my variable of integration is u. And the limits of integration were originally in x. Okay, you with me? All right, so that gets us this far. But then we're going to have to do a little algebra, aren't we? Because we've made a substitution, and I suppose we're closer to a solution, but it still requires a lot of work. All right, so negative 1 minus 1, negative 2. I can do that. What do you think I ought to do next? Divide by u. So we've got the integral from 1 to 2 of, well, then u divided by u is 1 minus, and then 2 divided by u, call it 2 divided by u. Or if you'd rather, you could call it 2 times 1 over u. Call it one of those two things, because from either one of those things, we can integrate it fairly easily. Okay? So either 2 over u or 2 times 1 over u, whichever you prefer. All right, now, what is the integral of 1 x, but not x, u, minus, and then the integral of 2 over u, or 2 times 1 over u? It will be 2 times, well then what's the integral of 1 over u? It's the natural log of the absolute value of u. And since it's a definite integral, no plus c, instead evaluated from 1 to 2. So let's evaluate. Do we evaluate for the 1 first or the 2 first? The 2. So that becomes 2 minus 2 times the natural log of the absolute value of 2 minus 1 minus 2 times the natural log of the absolute value of 1. Do I need the absolute value signs? No. 2's positive, 1's positive. They're not doing anything. So the first parentheses I can write as 2 minus 2 natural log of 2. So that is written as that, no more parentheses, no more absolute value sign. But in the other parentheses, what's the natural log of 1? 0. So all that becomes 0. So in that parentheses, 1 minus 0 is 1. So minus 1. Well, when I was in school, 2 minus 1 was 1. So that gives me 1 minus 2 natural log of 2, which I think is a perfectly fine answer. But probably nobody who authors a book thinks so. And probably the AP test, if this were a multiple choice, they probably don't think so either. What are they going to want you to do? Do what? Well, maybe. Maybe they'll want you to put it in your calculator. But even without doing that, I think there's something else they'll want you to do. Use computer software. A 2 that's a coefficient of a natural log, couldn't that also be an exponent? So use your exponent property. Make that 1 minus the natural log of 2 squared, and get 1 minus the natural log of 4. Any questions on 52? Okay. There's your assignment.